Here we go, everybody. Our last section. This is our last lesson. We'll do a little bit of practice. So we're going to do 11.7 today. We'll get to that in a second. So we'll do a lesson, a little bit of practice tomorrow, and then we'll wrap it up in a couple days with a test. And that's it. Crazy. Okay, so before we start 11.7, let me just do a quick little answer key check here with you from your work from yesterday. So if you need to pause this and go grab your yellow packet work from yesterday, let's check our answers. And I'll make some comments on a couple of these. Okay, so the most important thing to remember in both of these sections is to make sure you have the correct ratio. Okay, if you're missing any of these, that's the very first thing I would check. Did you accidentally use the side ratio instead of the area ratio, or the volume ratio instead of the side ratio, or something like that? Okay, so there's those. For 3, 4, and 5, I don't know if you saw my note about these. You don't need to find the actual areas. You just need to find the ratio of the areas. Okay, and in fact, you can't necessarily find them in some of these as well. Like in number 5, there's no way you could find those areas. And then, let me see if I have any more comments on 6, 7, or 8. So for example, number 8 is one of those where you just want to make sure that you're using the correct ratio to start. So look back here real quick. They give you, so those sides, these would be sides, 6 to 10, if you want to use the reduced version of that, that's 3/5. But that is not the ratio that you're using to find the missing area. We want 3 squared over 5 squared. That equals 320 over our missing area. We didn't have to do 9, so don't worry about that one for now. And so go ahead, if you need to go back and double check any of those, I apologize if I went too quickly through those. And then you just had 3 through 6 on 11.6. So you notice I have my volume ratio written down here. That's the one you should be using to find the missing volume. This one, I honestly can't remember if we did one like this in our notes or not. Did we do an example where we took a cubed root? Okay, so they give you the volume ratio 64 to 8. What we want is the side ratio. So the radius would kind of fall in that side bucket, right? We've got the side ratio, the area ratio, the volume ratio. So this 2 to 1 comes from the cube root of these numbers. You might have taken the cube root right off the bat here. The cube root of 64 is 4. The cube root of 8 is 2, but that reduces to 2 over 1. So it doesn't actually matter which one you use. They're going to reduce down to the same thing. Okay, and then 5 was just take those heights, realize that falls in the side bucket, cube those numbers to get the volume ratio. And then this one's interesting because you actually have to go, I think anyways, it's a little bit easier to go from volume ratio all the way back to the side ratio first, so that's taking the cube root again. And then once you have that, squaring it, right? So here's a cube root here. This is squaring the ratio or your number. And that's the ratio that you'll use. That one was a little bit challenging. Okay, so get your notebooks ready. Pause if you need to. 11.7, proportional segments between parallel lines. This is a pretty wordy conjecture, but I'm going to show you in a diagram what it means. So if you're comfortable just putting the diagram in your notes, that's okay with me. So here's what it says. Let me just do one part at a time here. If a line parallel to one side of a triangle passes through the other two sides. So here's a triangle. Here's a line parallel to one of the sides. It divides the two sides. So notice it broke these sides into pieces. It divides the two sides proportionally. Okay, so if these are my pieces, A, B, C, and D, I could say A over B is equal to C over D. Or we know we can rearrange these things a bit. You can go sort of across the triangle instead of along the side. You can jump across the triangle. A over C is equal to B over D. Those work as well. If you're not convinced that those work, just think about like your first step of cross multiplication here. You get AD and BC as your product. Same thing here, AD, BC. The converse of that is also true. So if you can tell that your sides are divided proportionally, then that line must be parallel to the third side. Oops. Okay, so if this diagram's enough, that's fine. If you prefer to write out the conjecture, that's fine with me too. Tomorrow I'm going to give you this proof as a little challenge problem. So there is actually a way to prove, if you're given this diagram, triangle with the parallel lines, it is possible to actually prove A over C. We have the letters arranged slightly differently. A over C equals B over D, but we'll save that. We'll see what that looks like tomorrow. And then the only other thing really for this section, it's a pretty quick lesson. We'll do a couple practice problems together. You can just extend this conjecture. So it doesn't have to just be a single line. So it says if two or more lines pass through ... So if you had something like this, it divides those sides. So all of those pieces are proportional. Divides those sides proportionally. So in this example, I could say, I'm going to go across the triangle here. 10 over 14. You see where I'm getting those from? 10 over 14 is equal to 20 over A, which is the same as 25 over B, which is the same as, careful with this one, C over 21. And then I could use any two of these at a time. So of course I don't want to work with all four at a time, but I could use, let's say, these two to find A, or 10 and 14 with this one to find B, etc. Might as well give you these here. This is 28. You can see this is doubled, right? 10 times 2 to 20. So 14 times 2 would give me 28. That's times 2.5. B is 35. And then C is 15. Feel free to find those if you'd like. We'll do a couple practice problems all the way through together next. Okay, so let me just do that here quickly with you. These are all from page 627 in your book. If you'd like to find them on your own, you're welcome to look those up. So the first thing you need to know, this does not work unless you know these lines are parallel. So M is parallel to AB. So if that's the case, I mean, it's really just set up your proportion. Just make sure you're doing it correctly. That's really the only piece that's new here. I could do one of two ways, either across the triangle, so E over 36 equals 35 over 45. Or if you prefer to go along the side, E over 35 equals 36 over 45. Either of those examples is going to give you, either of those proportions is going to give you the same answer. Let me just get that here for you. That ends up being 28. Let's just call it centimeters. I think the directions in the book do say just use centimeters for everything. Number one, I know this is a little jumbled, but that's intentional here. So number one, this one, it's really tempting to do this. I'm going to write this out and I want you to think about what's the issue here. 4 over A equals 12 over 20. So notice we've kind of worked our way, whoops, inside the triangle here. Okay, so I want to pause there for a second. 4 over A equals 12 over 20. That is incorrect. This proportion is incorrect. Let's think about why. So what's really going on here is we actually have two full similar triangles. We have this one here, and then we have this whole big triangle here. Oh my gosh, sorry. It's really hard, harder than you think to draw a straight line on this thing. Okay, so if I'm going to use 4 over A, which is fine, that's a full side of a triangle with a full side of a triangle. What's not okay is just to use, oh, this little piece over a full side of a triangle. So what we actually need is this full side as well. That should be 16. So what we really want is 4 over A equals 16 over 20. It is so easy to get this one wrong because we're just used to like plug in the numbers, set up your proportion, there we go. But this one's a little bit tricky. It's because you start working with these full sides of those triangles. Okay, that ends up being 5 for A. Okay, just watch out for examples like that. Okay, next one here. Now this one, it refers to the converse that we mentioned, so they want to know, are these parallel? is M parallel to FL. So what we need to figure out as well are those sides cut proportionally. So we're testing out, does 48 over 56 equal, put a big question mark here, 54 over 63. And just take those two ratios, divide them in your calculator, see what you end up with. Oh, I actually don't have that one done. Let me do that. So when we take 48 over 56, you get 0.85714, da, 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 da. 54 divided by 63 is the same thing. So yes, these are proportional. So yes, these lines must be parallel then. Okay, and then similarly here, this one takes it up one little notch, but same question. Do we have different parallel lines here? So let's pay attention to which lines they're referring to. So there's three different questions here. Is M parallel to EA? So let's just focus on M and EA. So that means I almost want to just pretend this is not here. So that means these are not individual pieces now. This is a full section. So 45 and 75. Okay, so to answer that first question, M parallel to EA, put these in here. We want to know, does 25 over, what is that, 75 equal 15 over 45? If you can tell, those are both a third, right? So that first question, yes, those two are equal to each other. Okay, so let me clear this off now. Let's try the next one. Now is an N, parallel to EA. Okay, so we want to know, I shouldn't put those markings in there. That's what we're questioning, are these two parallel? So that means that this does not exist. So that means now that we've got a big piece of 40 and a big piece of 65. Okay, so when we set this one up, I'll make sure I got that right. And EA, we want to know, does 65 over 35 equal 40 over 20? And this is where my eye is going right now. That's 2 to 1. This is not 2 to 1. So that's a no. Okay, so those are not parallel. There we go. And then last one is M parallel to N. So if, oops, I'm not meaning to mark those parallel, sorry about that. Are these two parallel? So that basically means like this section of the diagram we're totally ignoring, doesn't even exist. So does 25 over 40 equal 15 over 25? Okay. What do we get with that one? That is a no. You can divide those two. Those are not equivalent to each other. Okay, so that's a no. So the only ones that are parallel are M and EA. If you have that drawn out or printed out, feel free to mark that on the diagram. So this one, but this guy in the middle here is not parallel to those. Okay, so tomorrow, watch out for, I'm actually going to give you some practice problems and then that challenge problem. See how you can do with that proof. But that's it for today. Okay, quick lesson. Thanks, guys.